can see there's a few more people just joining at the moment. We'll give it a couple more minutes and then we'll get started. Thanks for your patience. All right, let's get started. Good afternoon, everyone. Good morning, everyone. My name's Stephen Ledig. I'm a solutions the public sector team in Australia, New Zealand. And I'm joined today by Ed Lima, who's also a solutions architect, who's going to be helping out with the questions and answers. We'll be taking questions throughout the presentations. So if you can put those through into the questions panel on your in your control pad, that would be great. We'll attempt to get through as many questions as we can this morning. But for those questions that we aren't able to get to today, what we're going to do is put together a fact sheet for all the attendees with answers, which we'll send out with a thank you email along with a recording or a link to the recording for the webinar. At the end of this presentation, we'll also be asking some poll questions, and we would really appreciate your feedback with those. So please hang around while we for those. So today we're going to be talking about building serverless web applications. Now, what we're going to cover in this session are some basic concepts around serverless, with specifically going to focus on two AWS services, AWS Lambda and API Gateway. And we're also going to be looking at some design patterns and some tooling that are going to help you get productive, get started with our serverless platform. So let's take a look at this quote. This is a quote that Werner Vogels, our CTO, said a couple of years ago. There is no server better than no server. Now, this was at the beginning of our serverless, the serverless revolution. Question is, what does he mean by this? To get a better understanding of what he meant, let's take a look at the evolution of computing as we know it today. So the evolution of computing has gone through several key phases, and each phase has significantly shaped the way that software is created and deployed, and all the ecosystems around it. Physical servers and data centers used to be the only way that we could deploy and run software at large scale. And we made these more efficient with virtualization. But many of the same basic hardware-driven limitations remained. And moving to the cloud really helped us free us from those physical limitations. But we still had a lot of work to do around building and scaling large software projects. It's fair to say that each step got progressively better. Moving away from physical hardware to virtualization gave us higher utilization of our computing resources. We were able to provision servers much quicker, and we had improved uptime. We had better disaster recovery scenarios and support for those, and we were able to take advantage of hardware independence. And moving to the cloud really allowed us to focus from moving away from a CapEx model to an OpEx model. We were able to scalability, we had much greater scalability and elasticity in the resources that we were able to consume, and even faster speed and agility to be able to consume those resources. There was reduced maintenance because we didn't have any hardware to worry about, and we had better availability and fault tolerance in the systems that we're designing, and automation has exponentially improved. We still needed to administer those virtual services. Still a lot of work that needed to be done. We need to manage the capacity and the utilization of those cloud resources, and we still needed to manage availability and fault tolerance. And in some cases, it was expensive to run intermittent jobs. So the next evolution on this roadmap is serverless computing. Serverless computing allows you to build and run applications and services without having to worry about the underlying infrastructure and thinking about servers. With serverless computing, your applications still run on servers, but all the servers are managed, all the server management is done by the service provider, i.e. us, so AWS. You no longer have to provision and scale and maintain those servers. You don't have to worry about installing or operating systems and patching them. And you don't need to worry about fault tolerance and the availability. That's all managed as part of that managed platform. And we do all this stuff for you. And so AWS Lambda lets you use serverless computing. So let's take a look at some of the Lambda concepts. Lambda is our zero administration event-driven compute service. You just have to worry about your business logic, and Lambda handles pretty much everything else. It auto-scales the underlying infrastructure as needed to match the call rate of requests coming through that service, and you just have to pay per execution, and that is in units of 100 milliseconds. It supports, you can write your Lambda functions in any of the supported languages for like Node.js, Java, Python, CSharp support was released last year. And we plan to support many other languages moving forward. So there are many benefits to using Lambda. The serverless application architecture patterns that Lambda provides you gives you access to new capabilities that will be used to build new kinds of applications. You don't have to worry about the serverless nature. Don't have to worry about managing. It reduces the operational overhead, and the configuration of your and allows you to configure your application much easier, allowing you to deliver more agile solutions and be more reactive to customer changes. The scale is managed by us. By default, you get 1,000 concurrent function executions out of the box. And because you're not having to provision any infrastructure, you're only paying for the amount of time it takes to execute your function. You're never paying for idle time. This is really optimizing your operational costs. And as mentioned, the availability and fault tolerance that's built into the service is managed by us. So here's an overview of the serverless framework using Lambda. As mentioned before, this is an event-driven service. And any of those events are going to kick off a function execution which has continuous horizontal scaling, and you're only paying on a per execution. Now, those events that started out in 2014 very humbly with a single event source in S3. Since then, we've grown that number of event sources to over 15. And this is something that this list is going to continue to grow. It doesn't actually account for the event sources or the events that you create within your applications. Lambda is proliferating throughout the AWS platform. We see now Lambda at the edge, which provides you the capability to specify Lambda functions that run globally across the Amazon CloudFront edge locations, our content delivery network. And it supports use cases like cookie inspection to rewrite URLs to different versions of the site for A/B testing, for example. Or you could use it to send different objects to your users based on the user agent header for your client applications. We could use it to inspect headers and authorizations tokens before forwarding those requests on to your compute resources at the origin. We're also seeing Lambda in embedded devices through our AWS Greengrass service, with direct local connectivity functions on the device that support IoT scenarios and device shadows to be able to cache and synchronize state across disconnected devices. And we're seeing AWS embedded in our Snowball Edge service, which is a rugged device that allows you to ingest large amounts of data into S3. And this allows you to run Lambda functions to perform tasks like analyzing data streams or processing data locally before you store that data onto that rugged device. And you will find that Lambda provides the extensibility points for many other services, such as Amazon Cognito and our developer services. So Lambda supports function versioning and aliases. Now, the version is an immutable copy of your code and your configuration. An alias is a pointer to that version. And this allows you to create a layer of abstraction over the various version, so you can point your client applications to a specific alias of a function, but move the underlying versioning around. So each version gets its own, or an alias gets its own Amazon resource number, so you'll be able to uniquely identify those within your application. And this scenario enables you to support rollbacks and stage promotions and provide this kind of lock behavior for your clients. Lambda also supports environment variables. Now, these are key value pairs that can be accessed in much the same way as environment variables are accessed on your local PCs, and they can be accessed through standard environment variable objects such as process env or the OS environment classes in some languages. We can also encrypt those for sensitive data. You can encrypt those environment variables through the AWS key management service, which is a managed encryption service. But you could also use your own client-side encryption for that as well. And so to put these things together, AWS Lambda supports the following use cases. Now we're going to focus on the web application side of things. So you could use it to build and deploy static websites or complex web applications, and even expose packages through Flask and Express for JavaScript applications. Supports building those complex application services that support mobile and IoT applications, and as well as we're seeing a lot more application at the data processing layer. So customers are using Lambda to do real-time analysis of data streams, map-reduce functions, and batch operations. And moving into AI and ML space, Lambda provides the underlying logic for chatbots and voice-driven applications through Amazon Alexa. And it's not just, and Lambda is not just about building applications. You can use it to invoke things that you can manage your IT infrastructure as well. So applying policy engines, extending existing AWS services, as well as managing your infrastructure and security within your AWS environments. Next, we'll take a look at the API Gateway service. Now, Amazon API Gateway is a fully managed service that makes it easy for developers to create and publish, maintain, and monitor and secure APIs pretty much at any scale. It provides the ability for you to create a unified interface for multiple microservices and has support for authentication and authorization at a per method level. And it also has support for throttling and DDoS protection out of the box. What do we mean by a unified API? Well, using API Gateway, you can really provide a single pane of glass to access resources that you're running on premises through publicly exposed endpoints that you yourself are hosting, as well as passing requests through to applications and services that you're running on Amazon EC2, Lambda functions, as well as other AWS resources. From an authentication perspective, it supports multiple forms of authentication and authorization. The first one is SIG4. So all of our services are signed using a method called SIG-v4. Now, this is a method of authorization authentication that allows you to invoke with caller credentials. Now, for the most part, developers that are working with our SDKs are don't have to worry about the underlying implementation of SIG4 and wrapping requests that are made to AWS services, because that's typically handled by the SDKs. But there are some services like API Gateway, which, if you want to use caller credentials, so your access and secure keys, then you'll have to implement those yourself. But we have support for identity and access management, so IAM roles, as well as integration with Amazon Cognito, using a number of different features of that service, such as the federated identity features, as well as Cognito user pools. And these these services can provide you with a per method authorization implementation. You're also able to extend your security implementation through OAuth and JWT custom authorizations as well. And this allows you to, this is really useful for bearer token verification. So we have the capability to provide a custom authorization logic, which can be extended via Lambda. We've also got API keys which you can use to assign your users and to bind those to usage plans, which allow you to control quotas and throttling for your APIs. And again, these can be applied to a per method authorization. So as mentioned, we've got DDoS protection built in. So this, the AWS Amazon API Gateway, has a CloudFront implementation which provides you those layer 7 and layer 3 protection levels. So you've got scalability through our CDN implementation built into the service. The throttling capabilities, as mentioned before, can be managed through integration with AWS CloudWatch. And CloudWatch allows you to assign metric, and in conjunction with usage plans, allows you to monitor the amount of traffic going through your applications. You're able to set quotas on the amount of data being passed through your APIs, as well as the rate at which they're coming through. And all of these are managed through API keys. As with Lambda, you all the scalability for that service is managed by us. And we've also got a caching implementation, which allows you to send requests from a caching layer back to your client without necessarily having to go back to your backend implementation for every request coming through. In much the same way that Lambda supports environment variables, API Gateway has this concept called stage variables, and these allow you to store things like configuration values. Now, the stage variables are very useful for defining the life cycle of your API. So what people commonly use them for are things like defining environment, development, production. And these stage variables are available within the context objects of the requests and are accessible through various parts of the execution chain. And including Lambda functions, HTTP endpoints, the custom authorizers that you implement from a security perspective, as well as providing you the ability to access them through parameter mappings that you have within your implementation. Next, we'll have a look at some design patterns. Now, one of the things that's we see a lot of in the industry is this move or people talking about monolithic applications. And what do we understand about monolithic architecture? Well, these are applications that really have been built up over a period of time that are quite large and have a lot of interdependencies. Typically, and we've all worked on one of these at one stage or another. These applications are really hard to change and to iterate because of the dependencies and the coupling within our applications. And this makes it really hard to scale efficiently. Typically, the only way that you can scale a monolithic application is vertically. So you can only go apply more resources to it. And this makes it also very difficult and time-consuming from a deployment perspective because of all the relationships between the various components of your system, and can quite often make it very difficult to deploy your applications. And there are also some reliability challenges around all of this because of the interdependencies and the size of the deployments and coupling within your application. Testing those can be time-consuming, and so our test cycles require a lot of regression testing, and can impact our ability to deliver rapidly. In contrast, we've got what's very popular in the industry today is this concept around a microservices architecture. Now, the concept of a microservices architecture is really about defining the natural boundaries within your application to create smaller autonomous components within your application, and being able to have make these components a single deployable, make these individual components or these verticals independent of each other and running their own processes. And making these components smaller makes them a lot easier to manage and allows us to iterate on them individually and provides us greater agility in our deployment. It makes it easier to scale as well. Not every part of your system has the same scalability requirements, and this and being able to isolate those processes and business functions allows us to look at the needs of each of those components and scale them accordingly. And because of this, everything is smaller, we're able to move much more rapidly and innovate on and try new things as we move through. Because our footprint is smaller, it also reduces the amount of human error within our applications as well, and minimizes or reduces the amount of testing and regression that needs to be done on the individual or the aggregate units for your solution. Now, a monolithic serverless web application can be the same concepts can really translate to serverless applications as well. Now, what does that look like? Well, from a Lambda implementation, we've got APIs that potentially have methods that are for multiple resources within our domain, and these are all handled by a single Lambda function. Now, there's some pros and cons with this approach. Now, this can make the application easy to understand. So your Lambda function is pretty much is contained as well, can be deployed much faster because you're only dealing with one function. At the same time, it can, because you've got a single handler that's handling all of the requests coming through, this large Lambda function can also be difficult to understand. And the added complexity involved in adding the building or in building the routing mechanisms can also lead to additional complexity within that implementation. And there's also a larger blast radius. So, you know, if any part of your application or your Lambda implementation fails, you're affecting pretty much the entire function. So again, this kind of very similar principles apply to serverless, monolithic serverless applications as they do to monolithic applications as we know them. So how can we improve this? So moving to a microservices architecture really involves looking at the natural seams and bounded context of your application, as I mentioned before, or breaking them into smaller autonomous components. Now, a microservices serverless web application, on the other hand, looks a little bit like this. Now we're looking at breaking our functions into much smaller parts. Now these can be at a resource level, or they could be at a per HTTP method level. And as we can see, we've got many more smaller parts to deal with. Now, the level of granularity, I will say this, that the level of granularity that you choose to, it really depends on your particular use case. So while this approach allows you to have teams that can focus on a set of Lambda functions, so you can align job functions or business function with the services that you're creating. You've got smaller separation of components, finer grain deployments. Again, from a CI/CD perspective, this makes it easier to deploy, and this can be much easier to debug because you don't have to, you don't have the same level of, you don't have the same footprint for your applications, and you don't have to worry about the same level of coverage that you would for a large Lambda function. This can also be a little bit harder to debug. You've got more moving parts. Your functions are distributed over a large area and interacting with other services, downstream as well. And in order to help with this, AWS has a service called X-Ray, and this provides you the ability to have trace, to be able to have trace calls and log those trace calls, so you can see the execution flow throughout your microservices implementation. We also got you also got more Lambda functions to manage, and so this can add to a bit more complexity around getting a bigger picture of what your microservices are actually doing. But to help manage this, we've come up with SAM. So SAM stands for Serverless Application Model. Now, a serverless application model allows you to build templates that define your serverless applications, and you can deploy those templates with AWS CloudFormation. AWS CloudFormation is our infrastructure as code service. It allows you to find templates in either a JSON or a YAML format, and has has the ability to define your infrastructure and environments through code. And so AWS Serverless Application Model is an extension of that service and is really optimized for serverless applications. Now it supports new serverless resource types, specifically functions and their event sources, APIs, so API gateway APIs, and simple DynamoDB tables. And because it's an extension of AWS CloudFormation, you can intermix standard CloudFormation with the serverless application model specifications, so you can grow your application organically and use all of the features that CloudFormation supports as well. Now, I've got the link here. The specification is it's an open specification and is available in our AWS Labs GitHub repository. So this is how a template would look if you were defining a simple, relatively simple resource, right? So this is about 5 times longer than a SAM template would be, and it defines. This particular example defines 8 separate resources, and you'd have to write, and still have to write a lot of code before SAM existed. The equivalent is something like this. So the serverless application model has really simplified this implementation. And so let's go have a look at what this looks like. So the key component that makes all of this possible from a transformation capability in CloudFormation is the transform specification. So when you add that declaration, CloudFormation knows that you're creating a serverless application model template. You can still create all the same resources that you did before, but now in this specific example, we're creating a serverless function type. And you have a number of different properties associated with that. First of all, you need to tell serverless application model where your code lives, what the entry point is for your function. So in this case, the handler property specifies the getHTML method within your Lambda function as the entry point. You can specify a runtime. As I said before, we've got a number of different languages that we support. Node.js. We also add a couple of different versions of Node.js. CSharp support, Java, and Python. Python 2 and 3. You've got the ability to define security policies. So you can use some of the IAM managed policies, or you can create your own roles and associate those to your function. And one of the really nice things about the serverless application models is you can easily define the event sources for your functions, and that's defined in the event property. Now, in this example, we're defining an event. We're defining an event source of a type API. Now, serverless application model will look at this and go, it's an API. I need to create an API gateway API resource. And what we'll do is it will actually automatically create an API resources that points directly to this function implementation. So it's really simple, really easy way to get started in creating your API resources and mapping those directly to function implementation. Last in this example is how to create a Dynamo DB table. And this implementation here is all that's really required to create a very simple Dynamo DB table. As you grow and as you evolve your application, you've obviously got the ability to change that to a specific resource implementation that CloudFormation supports and be more specific about the performance requirements of those tables. So there's an example of a serverless application model template. Now you can use this template to start developing and testing your Lambda functions locally with a new tool that we're currently rolling out in the beta format called SAM Local. And that's available in our AWS Labs GitHub repository as well. Now it allows you to invoke functions for known event sources for S3, DynamoDB, Kinesis, and all the other ones that many others that we support, and allows you to do all this locally. And we've got support for SAM Local has support for Node, Python, and Java, and it also has the ability to use the SAM template that you've just created and to host an API gateway resource locally, which allows you to quickly iterate over your functions, and it has even support for hot reloading. So highly recommend you check this out, and it's a really great way to start developing serverless applications locally. Now, while we're on the concept of while we're on the subject of development, we've got a number of different serverless frameworks that are available that the community has created that allow you to build serverless applications. We've got Chalice, which is a Python micro framework that AWS teams developed. There are other ones that support various different types of implementations. Claudia JS, serverless.com is very popular, and other ones through Sparta, Apex, and Zapper, which all support various different types of implementations, but provide an easy way for you to be able to build serverless applications. Now, let's have a quick look at Chalice. Now, Chalice is really, really simple to get started. Once you've installed Chalice within your Python application, you can all you need to do is really import the Chalice framework, define a Chalice application, and then decorate your function definitions with the app route. And you can so here what we're doing is defining a Lambda implementation, as well as defining the routing capability for the API gateway. And Chalice will then, once you deploy your framework through the command line, it will actually go ahead. It will create all the necessary. It will provide all the necessary functions in order to deploy your Lambda function, apply the appropriate security models, create your API endpoint, and map that to the function implementation for that particular resource. And that can be easily tested, through various command line tools that are available. And that's in a few lines of code you can get started really, really quickly. So if you're in Python, if you're doing Python development, I highly recommend you check Chalice out. Another one is Claudia JS. And in this example, it's very similar to the Chalice implementation. Once we've implemented the libraries, we're able to create an API with an implementation that is a lambda function. And this is a Claudia JS supports Node.js, and so you'll be able to support. It's a really nice framework for able to get started really quickly. And then creating your lambda function, Claudia will you can provide the command line tools that are available that can execute the deployment and management of your serverless applications as well. So wrapping up, a couple of things to remember. If you're getting started and you want to start building applications, have a look at the serverless application model. It's a really good way to get started, to start on the right foot around how you manage your microservices applications and your serverless applications. There's lots of frameworks there also to help you get started really quickly. But a small piece of advice is, if you're only getting started with serverless, then start small and build up and build your confidence level and your capabilities around the platform, and use the frameworks and the tools that are available in the community and support that the community provides to help you get started. Now, this is a bit of a plug for some serverless workshops that we're running across Australia. Unfortunately, we've sold out. These are free workshops that are available. We do have spots left in Adelaide. So if you're from Adelaide and you would love to get a free workshop and join the team there, then we still have some spots available. Otherwise, please do let us know if you're interested in hearing more about serverless workshops, and we can let you know when new ones become available. And that's it. Thank you very much for attending. And I think we still have a little bit of time for some Q&A. So just pass those through. Thank you very much. Just before we go, if you wouldn't mind just answering some of the questions around the quick poll, we really would appreciate your feedback. Thank you very much. Just a reminder to everyone, we will be making this presentation available, and we will be putting together a fact sheet for any questions that we aren't able to answer today, and sending those out to all attendees. So you will get a link to the presentation after this. Thank you. Okay, just going to go through, there's a couple of questions that have come through while we've still got a couple of minutes. One of the questions here from David is, what frameworks are available for C#? Well, there aren't any frameworks per se that I'm aware of, but what I will say is that the AWS .NET SDK team have got lots of support for C# inside Visual Studio. So if you go to aws.amazon.com/Visual Studio, you'll get information on how to download the components that allow you to get access to AWS resources. Now, once you've installed those tools inside Visual Studio, you get a number of different project templates and sample implementation projects. So and that includes Lambda. Now, the C# tooling, C#, there are some caveats. It's not a full framework implementation. It's you need to be running .NET Core 1.0 at this point in time, but there are project templates that and sample implementation through blueprints that allow you to easily get started. So once you've got your application inside Visual Studio, you'll be able to pretty much treat it like any other project that you would as well. So highly recommend you check out that. That's a good way to get started with C# development. How do we? Andre's asked, how do we constrain Lambda costs? Well, it's a bit of a open-ended question, but there are a number of different ways that you can manage costs within Lambda, and one of those is obviously having a good understanding around the performance requirements of your Lambda functions, specifically around the amount of time, finding the relationship between applying the appropriate memory configuration and the amount of time it takes to execute your function. So sometimes it's better to have more memory, because there's a correlation between memory and CPU allocation for your function configuration. And if a Lambda function executes quicker, that also lowers that can potentially lower the amount of time it takes to execute, and also reduces the billing cycles. Remember, we bill in increments of 100 milliseconds, so that can actually make the difference. I mean, it really all depends again on the nature of your application and the scale of your application. But they're just some sort of basic ways to do that. I've already answered the questions around C#. Again, Visual Studio tooling on our website is the great way to get started with C# Lambda. What is the, hang on a second. What else we got? Ancan has asked, is there any sample application with best practices followed for serverless? Example, CQRS pattern using Lambda. So there are a number of, I don't know if there's any specific CQRS examples out there, but if you have a look at the AWS Labs website and search for Lambda or serverless, we do have reference architectures available on our GitHub, AWS Labs GitHub website. So you'll be able to find some sample implementations there. Does Lambda support events from SQS and SNS? So it does support events from SNS. SQS, you would have to at this point in time, you'd have to create a polling implementation through something like CloudWatch log scheduled tasks. So if you want to consume messages from an SQS queue via lambda, create a scheduler, and that scheduler then invokes the lambda function that you want to be able to that's consuming those messages, and that is the simplest way to implement SQS with lambda. So a question here from Shrivani is, lambda written in Java, does the execution cost include warm-up time? No. So again, the execution cost is really the only time it takes to execute the requests coming through. Can you keep, Michael's asked, can you keep track of utilization on CloudWatch? Yes, you can. We've got a number of different metrics that are available through CloudWatch. You've also got integration with CloudWatch logs, so you'll be able to output all your logging into CloudWatch logs. And there are a number of different third-party tools available that you can use to monitor lambda activity. Okay, there are a few other questions. I'm going to probably not going to get through all of these, and hopefully Ed's been able to answer many of your other questions as well. And we'll get back to you with any ones that we haven't covered, put together a correlation of all the questions that have been asked today, and send those out in the email. So Shivani, to answer your questions, can I get a question? Can I get a link to the questions? You will get the questions sent to you. Just to, there's another question here. Are we able to share the presentation? Yes, you will get a link to the presentation deck at the within as soon as we can possibly process it. So yes, you will get that as part of the attending today. All right. Don't see any more questions at the moment, so I think we'll leave it there. Again, thank you everyone for attending, and enjoy the rest of your day, and join the serverless revolution. Thank you. Bye bye.